Alright guys, it's about 7 minutes till 10, and I'm sorry that it is so late that I'm getting to this, but I did promise you that I would get some done tonight, so I am going to go through one or two from each section to make sure that you're understanding what you're doing. I had some things come up unexpected, and sometimes life happens and you just have to take care of things. But let's get a few of these knocked out so you can take a look at them later tonight or first thing in the morning when you get a chance. Alright. The first one we're looking at is number 2. No, you do not have to graph this. We're just identifying the vertex, the axis of symmetry, the minimum or maximum values, and the domain and range. Okay. So, we're going to start out, we're going to look for the x in our vertex. So, I need something for my vertex here. So, we'll find that out in a minute. I'm going to look for my axis of symmetry. So, remember, x is equal to negative b over 2a. Okay. So, b is 2, so we have negative 2 times 2 over 2 times, and then a is negative 1, so I have negative 2 over negative 2, or 1. So my axis of symmetry is x equals 1, and that's the x in my vertex. Alright, we're going to take this x, and we're going to plug it in for the x in our equations. So I'm going to have negative 1 squared plus 2 times 1 plus 3. So I have negative 1 squared is 1. Plus 2 times 1 is 2, plus 3, gives me negative 1 plus 2 is 1, plus 3 is 4. So that's my y. Okay, so that is the y in my vertex. So my vertex is at 1, 4. Okay, now, my minimum or maximum. Well, I look here at my A, and my A is a negative, so I know that it opens down, right? My vertex is up on top, and so I know that I'm looking for my maximum, okay? So my maximum is at my y value. Okay, so my maximum is at 4. Okay, so what would that make my minimum? Well, my minimum, because my minimum and it's opening down, that means I'm not going to have a minimum, so I have the empty set. Okay, now my domain, like we've said today, for all quadratics, my domain is all real numbers, okay, or negative infinity to infinity. So what's my range? my range now remember, it starts at the top and goes down, so that means it starts at the lowest end at negative infinity, and it goes up and stops at, that's right, 4. Okay? So here's my equation. Oh, that's not my equation. Here's my original equation. My vertex is at 1, 4. My axis of symmetry is at 1. My maximum is at 4. I don't have a minimum. My domain is all real numbers, and my range is negative infinity to 4. Or y is such that y is less than or equal to 4. Okay? Alrighty, let's go do the next one. Alright, let's look at number 6. Number 6 is y is equal to negative 3x squared plus 4x. Okay? Again, we're looking for our vertex, our axis of symmetry, our minimum, our maximum, our domain, and our range. Okay? Alright. Again, x is equal to negative 2. Oh, nope, let's try that again. Negative b over 2a. So, negative b is negative 4 over 2 times a is negative 3. Okay, so that gives me negative 4 over negative 6. And that is, reduce that down by 2. So that gives me negative 2 over negative 3, or positive 2/3. So 2/3 is my x. So my axis of symmetry is x equals positive 2/3. Alright, now let's plug this into our equation. So when x is 2/3, we have negative 3 times 2/3 squared plus 4 times 2/3. Alrighty, so 2/3 squared is negative 3 times 4 over 9 plus 4 times 2/3. Okay, so let's see where that comes out to. I have negative 3 over 1 times 4 over 9. I'm going to reduce this by 3, and that gets me 1. I'll reduce the 9 by 3, and that gets me 3. That gives me negative 4/3 plus 4 over 1 times 2 over 3, and that gives me plus 8/3. So I have negative 4/3 plus 8/3 gives me 4/3, or 1 1/3. Okay, so my minimum, again, this is a negative, right, for my a, so this opens down. Okay, so opens down. And so my minimum is how far down does it go? It goes on forever, so I don't have a minimum. My maximum is at the top. So my maximum is my y value at the top. So it is 1 1/3. Okay. My domain, again, let's write it in interval notation this time. In set notation this time. So x is such that x is equal to all real numbers. Okay. And then for my range, y is such that y is less than or equal to 1 1/3. Okay. Alright. And that does it for number 6.